Hi all, welcome to another session of SD Skills. Today, Shreya is going to present on containers. And with this, let me pass on to Shreya.
Hey, thanks, Asim. Before jumping on to containers, I would like to start with what kind of problems are there that we face and why do we need containers so that we can have a better understanding of the need for containers. So, for example, the problem was deployment. Like how deployment was done traditionally, um, not when containers were there. So people used to, or companies used to use like one software per machine. And when they use one software per machine, then that is a possibility that that particular software did not use all the resources that were required, right? For example, some software, if the system requirement was like there was some 16 GB of RAM and then there was 1 TB of hard disk, but if the software is using, for example, just half of it, then we are basically not using all the resources in the system. We are not utilizing the complete storage, complete memory. So in such cases, right, what companies started doing is that they thought that probably to utilize my machine better, I should place more than one software in a machine. So can anyone think about like what could be the problems if we have like more than one software per machine?
Maybe security is one issue.
Yeah. Uh, and anything else?
Maybe we cannot give like assume that we have a 6 GB RAM and to one machine we want to give 4 GB RAM and to another we want to give 12 GB RAM. If we simply deploy two machines without the containers, maybe we cannot do that.
Are you saying that we cannot tell in prior like how much will be the system requirement? I couldn't understand. Sorry.
Yeah, I will repeat. So assume that I want to deploy two servers in my EC2 machine, like using AWS. I want to deploy two Tomcat servers, two different like it's two different softwares. So
Uh-huh.
I to one software I want to assign 4 GB RAM, to another I want to assign 12 GB RAM.
Okay.
So both are compatible. I'm just assuming,
Uh-huh.
and other CPU and other.
Okay.
So for me, it looks like the problem is deployment when your one system is shared by a lot of softwares or thing. There are possibilities that you change one, it could spoil the other one. There is no isolation between softwares. They can go over each other, and it could be possible when you are deploying one, it could it could it, it could be a downtime for others also. So 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 there is so this DevOps is not that streamlined in that case.
Mm-hmm. Yeah. Most of you, whatever you have said, it's correct. Actually, whatever you have said is correct. So basically, there could be multiple problems because both our software is using the same file system. Then there could be like dependencies that they could be sharing, and both of them can have like different dependencies. The other problem is for example, I know like whatever two software that I'm running will be able to run in the system that I am providing them. Like they have enough RAM, they have enough storage, but still if one software gets corrupted, then it might have side effects. So I can probably draw a small diagram here and show you. So let's go by case. So let's take the first case where we have this software 1 and this software 2, and they're running this on one host machine. Okay, and this software 1, and let's say that our RAM was 16 GB here, and this was using 8, and this was using 8. So we knew that they will always coexist. But something happened with S1 and it started failing. And with this fail, it started consuming more RAM than expected, right? So now since this is consuming more RAM, this software is now, we know that this software is now will have a side effect that this software, the software 2, will not have enough RAM to run because it will be low on resources, and because of this software 1, software 2 will also come down, so they'll fail. So the most important term here that Asim used is isolation. So we want something so that this doesn't happen, like one software should not impact the other software. So this is one case. The second case is because these two system exist these two software, sorry, exist on one host, the underlying file system is same. So for example, if this was some Linux system and they both were accessing some for example, they both wanted to run some server, right? Let's say they were running some web server and they had some file in opt slash, for example, nginx, some conf file. And since now there is this one file, S1 would like to go and make some changes on this. S2 will also go and make some changes on it. So actually this file, whose changes it should keep, right? That is also something that we don't know. So this will definitely cause some problem. That what
So
exactly?
why can't they create different files?
Sorry.
Why can't they create different files for their config? Why are they keeping same files for their config?
You can create, but like first of all, like nginx.conf, I mean, you will have to do some weird stuff probably, that you will have to configure that at least one of them takes from a different place, right? And something like in nginx, what happens is when you restart the whole because it's like a package, this server, so it's whenever it starts, it reads from this place like nginx.conf. Then you will have to make changes all the way up till, wherever that configuration file, that service restart file is there, you will have to probably go and update the paths everywhere for one of the softwares. So it will have like lot of changes, which is unnecessarily. If I could like just make like two copies of nginx.conf here and here, but that is not possible, right? Because I need the service, this web server, to be able to use the packages that are already installed here, and to be able to start it, stop it, and do like whatever command line functionalities are provided by nginx, right? So
Okay.
if I want to do it from S1 and S2, I can just directly call those commands from probably a shell script. But if it is not there, like if I make a copy for S1, then I'll have to update in all the places for S1, like wherever that I'm making the copy. Okay.
So the main thing is say softwares are on the same machine, they're sharing all the resources,
Mm-hmm.
and we don't know if one person can starve the other one.
Yeah,
So these things are there, and looks like there is another problem in this design is how the scaling will work.
exactly. Yeah. For scaling, like if this scenario could work, then I don't know. I mean, I could be wrong here, but cannot we, if this S1, S2 could coexist without any dependencies and without any like without any, if they are sharing resources also, but still they are able to coexist, and they don't have any side effects, can we not just copy them like on multiple hosts?
Yeah. So let's say if I have to, let's say S1 is, we need to only scale S1. So that means I have to also copy S2 on the other machine. Let's say we are talking about horizontal scaling. So basically, if I want to horizontal scale, I have to horizontal scale everything, if it is needed or not needed. And if I want to do vertical scaling, then also if I add more resource like RAM memory, then how I will make sure that it is going to S1 and S2 is not trying to starve it.
Yeah, good. Both are good points. Yeah.
So, so I think like 10, 15 years back, this was the model we used to follow in the industry. And with the kind of, that time we don't have that much load, scale, and everything was actually okay. A few number of users, but with the number of users got increased with that type of requests we get, then this design start to crash, which used to work in the industry really well for a long time, but then there is a need of change.
So, but Asim, one question about scaling. So, what is the problem in scaling? Why can't we copy this software one and software two?
We can copy. There is no issue in that. But let's say so S1 does not need to be scaled. Only S1, S2 needs to be scaled. But we are not copying. Now we are copying everything. And you see the time of copy. If there are 10 softwares on box 1, and if I have to copy everything to box 2, it will take time. It won't be instant.
But why will you copy both of them? Like if software 2 had more load, you will only need copies of software 2, right?
So, so your deployment, if your deployment logic can handle that part, then it is good. But if your deployment logic doesn't know that, and that time these all logics were not there, then the deployment was very simple. Like this box has this all softwares, and then let's copy to let's take the image of that box and replicate to other box.
Okay. Yeah, got it. Okay.
But I think Shreya would explain us with containerization how easy these things become now. But these are the problems. Like you have a kind of a monolithic box with everything. Now, if you have to replicate, you have to copy everything. That's what I have seen. Might be there would be better things that time also, but because I have seen in that way. And actually, there's no concept of scaling that time. Because you make sure like you have actually 10 boxes running with these all softwares, used or not used, doesn't matter. But if the scale grows, then you have 10 boxes which could handle that. If there's less load, one is also fine. But there's nothing like you remove or add anything. Kind of fixed configuration.
Okay, that was really good. Okay, then to solve these problems, first virtualization came into the picture. So just a second, I want to erase this board.
Yeah, you're not sharing your.
Oh yeah, I'm just erasing my board right now. So so basically, like after this, virtualization came into the
I
picture.
think your board is open on another machine, so you have to open it on this machine also.
Right now we're seeing your PPT.
Yeah, I'm just talking about PPT right now. Do you want to see that here? Actually, I was erasing it.
Okay, yeah, okay.
So yeah, I was talking about virtual machines. So before containers also, like people came up with the idea of virtual machine because they provide us with the same thing like isolation and scalability. So with this, what could be the problems? Let's discuss that. Like why virtualization, which seems to be a good idea, why that can be.
Is this Shreya that one big OS like a hypervisor running couple of machines.
Mm-hmm. Yeah, so it's basically, yeah, you have a hypervisor layer and now you have multiple operating system running on it. And then your
Mhm.
software is running on that particular guest OS. So yeah.
So I see a problem here that just bringing one machine up, it could take time, because when you say a machine, it could be Linux box or a Windows box or a Mac box. So although you have a provision, so basically what we are saying here is S1 and S2 would live into different boxes. So initially the big box which you showed, now it's like a hypervisor. On top of that, we installed small OS, and then S1 and S2 would live into that. That's what we are saying.
Yeah, that's what we are saying. Mm-hmm.
Okay, so I think, yeah, so that was a phase 2 of evolution, where industry thought like, okay, hypervisor is there, let's start putting boxes there with its own individual softwares. So if you can draw that, I think that would be.
Yeah, I'm drawing. This software is not very good.
I think there is a big erase. Okay, never mind.
What is the shortcut?
I think the eraser size you can increase, but never mind.
Yeah, I am actually, the eraser size was 2 and then I increased up till 7. Like that's the maximum.
Okay.
Or,
Sorry.
yeah,
Yeah.
maybe next time you can try Control A Delete, like the standard, which
Mhm.
works.
Okay. Yeah. Mm-hmm. Yeah. So I'm drawing now.
So the big box which you showed earlier became a hypervisor, right?
Yeah. So now this is like the machine, and we have our host operating system, which is like whatever the machine is running over here. Then we have the hypervisor layer,
Mhm.
which will basically share the resources with these guest OS.
Hmm.
Yeah. So this is what will happen here.
And guest OS will now have S1, S2. Is it
Yeah,
something like
they will have this S1, S2, S3. Yeah. So
So
now,
now the problem of isolation is solved.
yeah, now the problem of isolation is solved. And problem of like resource sharing is also no. Like here one VM can still take more resources. Yeah.
Yeah, but it's
There
kind
is
of
no penalty.
controlled. How much we'll give to guest OS by
Yeah,
hypervisor. It can't go beyond that.
beyond that, yeah, agreed. Yes, you're right. So yeah, that problem is solved. But what is the problem with this approach? Why do we need containers?
Yeah, so again, I think let's come to our initial points. Uh,
Mm-hmm.
I'm thinking in terms of scaling, but audience can also chime in. I
Mm-hmm.
feel like scaling is still a problem.
So one thing I can think of is like here there is a separate OS. Previously, S1 S2 runs in one OS. So each VM has its own OS. So it takes few minutes to load spin off virtual machine. So that's one of the downside compared to Dockers.
Okay. Yeah, that's correct. Actually, yeah, we for running each software we have to have its own complete OS, which should have everything, file system, kernel, and all, so that it can do whatever it is designed to do. Anything else?
So, but this now something came to my mind. So
Mm-hmm.
actually, this design was actually good. If S1 is like a monolithic service
Mm-hmm.
doing a lot of operations, running on a guest OS is a good idea.
Okay.
And but as soon as the industry started looking towards microservices, then this was not a good idea. because your microservice itself is so much light. It does not need the entire OS thing to run. So that's why something coming to my mind. Please correct me or.
So Asim, is you're saying that if we are using a monolithic service that is usually big, so generally you will be deploying one monolithic service on one machine because monolithic services are heavy, so they need a lot of resources and all. So you will be using one machine. But when we came to the microservices era, then each of these services were small, and these small services were not taking enough memory resources, enough system resources. And so we used to have a lot of free resources in each system, which were not properly utilized. So
Yeah.
then wanted to do the optimization and deploy multiple microservices on same machine so that we can make better use of our hardware resources.
So think in that way. You have a monolithic. So actually, this thing worked really well for a while, because when you have a big monolithic service having its own guest OS, isolation really worked well for a while in the industry. And but the problem was, let's say S1 is a monolithic service, and if I want to scale, there are two problems. Let's say now I have to first replicate guest OS. And the other part is, even if I'm able to replicate guest OS, I have replicating the S1 monolithic service could also take time, because it's a really big service. When it boots anything it does, it takes time to, it needs memory, CPU, everything. So it needs a proper OS, basically. That's what I'm trying to say, if it's a monolithic service.
Yeah, and like basically if you're talking about monolithic versus microservice, then like one of the issues I see in scalability is that your monolithic service has a lot of components as one monolith. So even if you wanted to scale just one component, because it's a monolithic, you will be creating copies of entire service. For example,
Yeah.
my authentication, my login system was most oftenly used. And I just wanted to scale the login component of my service. Because it's a monolith, I have to create copy of my entire monolith. Whereas if it was divided into microservices, I could have just created replicas of that just login system because it was getting a lot of requests. So now that was splitted as a microservice. I have created a lot of copies of that. And so that only is
So
having.
I think the same problem which we discussed earlier. Let's say S1, S2, S3 is not a separate software. They are one monolithic service, and now we have to replicate. We have to replicate everything. But this entire big service could not live on a very lightweight OS. It needs a full-fledged OS to run.
So let's say I have multiple microservices. Let's say each microservice is running a Tomcat with port number 80. Okay, so I have multiple of them with port 80, and then how would like each service gonna have its own IP address and port number, and then if I'm outside of the I'm outside, does it handle the IP address and the port number?
I think we should park this question for a while, because we haven't reached till microservices yet. Right now we are on the monolithic.
Yeah, but that's still related to the, let's talk about, not talk about microservice, let's talk about guest OS. Let's still need to have port number and the IP address.
Guest OS having a monolithic service, and we are good with that. But we haven't talked like breaking monolithic to microservice yet.
But wouldn't that each of them need to have the IP address and the range of port?
Yeah, that's what then Shreya will tell us how containers will help.
Okay. Yeah, so we were discussing the problems about it. And there are some advantages to it also. I think that like whatever guest OS you're running over here, it can be independent of whatever the host OS is, right? And we'll see in containers that that's not the case in containers. So like it can independently run over here whatever software you want, but that is not something which is possible in containers. You need to have the host OS which is compatible with the container OS. So we'll come to that in some time. Anything else that anybody wants to point out? Because I might have missed some points. It's totally based on what I have the knowledge about this system, right? So feel free to chime in.
So basically now, Shreya, you are taking towards us to containers, right?
Yeah.
Like why we want to use containers. So, but before that, we started splitting we want to split monolithic. Was that the motivation behind that?
Yeah, that was the motivation behind like this.
Can
So
you
containers came
explain?
because of microservices.
Can you explain why duplicate file? I thought like we have separate OS and each of them we store their own file.
Oh, duplication of files. For example, like if S1, S2, and S3 are running some softwares which need, for example, all of these need some web server, for example, Nginx. So my guest OS will also install Nginx. This guest OS will also install Nginx, and this also. Uh, or maybe something like, if all three of them wanted to run something like Ruby, or like something else like Rails or something else which can run on top of Ruby, every guest OS will need to install Ruby here now. But like this could be something which can be optimized, like there could be just one OS which could install Ruby, and then on top of this, when the software were isolated, they can run in such a way that they can all use that particular feature of Ruby and then could access it. So like, for example, this could be running Rails or whatever, like S2, S3 wanted to run.
So let's say we have 10 OS, but only one OS need Ruby, and then we have to install Ruby on it. That's what you're saying, right?
I'm saying that if you wanted Ruby for both the three softwares, then on you will have the Ruby in guest OS, you will have the Ruby in guest, like all the three guest OS. I'm saying that this could be optimized in such a way that you have the host OS with Ruby, so you install it here instead of there, but S1 should be able to access the host OS.
Okay.
That is some change. But like in VMs, that's not possible, right? Because softwares cannot access host OS. They can just access guest OS.
Just a question, like in containers, don't we lose the like isolation as we are using the uh, same machine, like same Ruby platform?
So I think we have not discussed containers. It's virtual machine up till now.
Yeah, like okay.
So in
Yeah.
like each of them has their own OS, so that's why they have to create replica of Ruby in all of the guest OS.
I think one of the main things maybe we didn't touch upon is the fact like the hypervisor is not very effective OS. It takes a lot of resources for the hypervisor to manage the multiple OSs that are running on top. So hypervisor is not a good approach to solve that. And when we kind of go to Dockers or containers, you are effectively eliminating the hypervisor, so you're talking directly to the host OS.
No, but eventually all the cloud providers initially started providing this, like for example, hosting a EC2 or something. They providing really quick ways to just host a EC2 and be done with that.
Right, but the other thing is like, no, maybe earlier there was these servers which were very big in size. So no matter how much you deploy, you would have to have multiple OSs to split it up. But going forward, they started picking up smaller machines where you can deploy multiple instances of Docker and be done with. So you don't really have to have partition the whole machine into like a lot many segments.
Yeah, but the motivation, I think that's what my understanding was they want to split the microservice and to split a microservice and put it into its own individual OS, this thing was not sufficing the need, because again we end up like a lightweight component we're putting on a guest OS. Hey, Shreya, can you switch back to your drawing thing, please?
Yeah.
So what I see a problem like S1, we thought, okay, let's break S1 into multiple components, and I can annotate actually. Okay, yeah. So this, let's say this S1 was a monolithic. Then I started putting S11, S112 here, and S113, like different components, like Abhishek told. Identity could be one component, and like logic, business logic would be another component, and that's what. But now these components are light in size, but we are putting them on a guest OS. And if I want to scale this component, the problem still lies with that. That this guest OS needs to be replicated, and this replication time could be like, let's say, 2 to 3 minutes. So by that time, our scaling is going slow. Although we make our component light, which can deploy like in milliseconds, but replication is still a problem. And to answer Leon's question, the idea was never a microservice to deploy multiple microservices to deploy on one OS, because then again, the same problem will come, like how we started. So the idea is like one microservices on one guest OS, and then start replicate. But now the problem still lies in replication of the guest OS.
So you don't replicate the guest OS, you would share the guest OS. Then wouldn't that be a problem?
Sorry, come again.
If let's say you don't want to replicate the guest OS because it's heavy and it takes time, right? Mm-hmm. And that means we have to share the guest OS. Is that right?
No, why we want to share? Let's say S1 could not, S11 could not be able to scale on guest OS. Either we'll vertical scale or we want to put it on some other box. Why I would put S11, S12 on the same box, where S11 could not be able to get handled properly.
Then we have to replicate the guest OS.
Yeah, that's what I'm saying.
So I think the other aspect is that if you look at the memory consumption, right? So think about each OS takes, let's say, 4 GB, like in the basic sense. And now the 4 GB, it's like it can even occupy 2 GB for its own working. So essentially you have 2 GB here, 2 GB here, 2 GB here, 6 GB is just gone in 6 guest OSs. Then you have hypervisor taking certain amount of gigabytes here. And then you also have host OS, which is kind of also consuming something on its own. So now if you collapse all of these, right, the guest OSs, the spaces, memory they occupy, the hypervisor, you can do a whole lot with just being on top of guest OS. So from a memory management perspective, it is also very efficient. And then if you have basically smaller machines, then you can quickly just do that without wasting or allocating all the resources to whatever their task at hand is.
So are you saying like the idea of smaller machines, the container idea came from the smaller machines?
Basically, it came from the fact that the way I try to explain, right, that I said like if each guest would think about X 2 GB, right, natively, that at least I need 2 GB here, 2 GB here, 2 GB here, right? So I lost 6 here. I lost 2 GB in the hypervisor, and now in the whole OS, like the actual machine, let's say I had 4 plus 4 plus 4 and maybe 16 GB. So essentially my 8 GB kind of got lost in just installing these core components. And now
you're saying like collapse everything together.
Yeah, collapse everything because
so that's what where Shreya started. Everything was on the same system, and then we split that because we saw issues there.
Right, and then the other aspect of the maintenance, right? If these OSs are identical, you need to work and maintain all the OSs, patch them up to keep at same levels. And then lastly, if you think about the boot up time, right? Now each OS will take its own sweet time to boot up, right? So now you're waiting so long for everything to start up from ground up. The host OS boots up, the hypervisor boots up, each of these guys boot up. Now you're in service. as opposed to if you want to just boot up your host and then kind of use some sort of Docker technology, which are more lightweight OSs or containers in a way to do the same.
I think two factors here. One, we want a lightweight component which could be boot up really fast, and we also have a lightweight component of a microservice. So they go really hand in hand. If I can't deploy a monolithic on a container, it will crash. So when we went towards this microservices world, then containers worked really like a charm.
Yeah, because as somebody will kind of go through the Docker, you'll see there are other benefits that Docker bring in place to further help it out. Right?
Okay, I think we can give it to Shreya. That's her session, so she can guide us here.
Okay, yeah. So we discussed like what were the problems with the virtual machine, and so now we know like our resources are not getting optimally used. We don't have isolation, and we need to have a way so that we can limit like which software should be using how much resources, right? So for that, the container came into the picture. So container is nothing but a running image. I can probably make a diagram of it, and then you can visualize how it is different than the the current system, like virtual machine system that I made over here. So Control A and delete is not working actually.
Hey, I think you can select from that top left that
Where?
the top left. There's the arrow sign, right? That is
Yeah.
kind of selector. Top left.
Okay. Yeah. Next time I'll do that.
Yeah, that is selector. If you select everything, I think then it would work.
Okay. So for that, so now we are seeing like how a normal container would look. So now we have our host operating system, just like a virtual machine. Then we have some runtime engine or files. And then we can just run our app on top of it. So this is something, yeah. So this is what a container would look like. So there will be host operating system, whichever you want to install. Then there will be some runtime engine like Docker or LXC, or there is something called as Core OS Racket. And then you can run your application on top of that.
But these applications will be running in container, right? So there is
this is container. Like basically there will be okay, I can make this will be a container. Yeah, application will be running in it, and there will be something over here. So there will be another layer under this runtime engine that will be like base OS is something that we need. So the difference is that this host OS, it will have a file system plus kernel, okay? And the base OS, it will just have file system. So it's very lightweight. It doesn't have kernel because for all the operations and system calls, we rely on the host operating system to do everything for us. So basically there is something wrong over here. Wait. So we need a runtime engine first and then the base image. So this is runtime engine, basically Docker or something. And then here it will be like the base OS, the image that we will create, because and that application will be part of the image. So I actually cannot exactly say this because like imaging is something which is layered in containers. So I cannot say that this is just one image, although it will look like one, but they are basically layers of images. So there will be something called as base image, which will be like your operating system that you want to have. For example, you want some X system. Let's say you want Ubuntu. So this will be your base image. Okay. And then on top of it, you can run your any software. Let's say here that we want to just run some web server. So you will have the web server image. So like there will be image inside an image, and in total, like in complete, this will be one container. So container is nothing but, like, you can understand, it's a running image, and it is also made of layer of images. This is what a typical container would look like from inside.
So is it possible like I can merge all images into one image?
Yes, you can, but you shouldn't do that, because, like, first of all, we talked about that resource utilization, right? If you merge everything in one, first of all, it is very difficult to maintain, right?
No, when you say base image, what exactly it means? Like, is it would be lightweight OS or
Yeah,
something?
it will be a lightweight OS. There are some lightweight OS called BusyBox, and there's another, I forgot name of it, but yeah, there are some lightweight OS. You can take that as base image. Basically, a base image should be something which just has a file system.
Very
It should
basic
be,
thing.
yeah, very basic thing. And other thing is, it should be compatible with your host operating system. So that.
But I think runtime would handle that. If let's say if that runtime is a Docker,
Mhm.
then it doesn't matter what is the OS. That's
Yeah.
like so that would be like something like a Java runtime environment. You install in any system, then doesn't matter what you are running on top of it.
Yeah, you're right. Yeah, there is Docker desktop that is created for this purpose, that it can run on Mac, it can run on Windows, it can run like on any
Mhm.
system, right? Any operating system. Yeah, you're right. It is correct. But like if you don't have anything, like if I talk about just LXC, like Linux containers,
Mhm.
then your host operating system, for example, you're using Ubuntu certain version, and
Mhm.
then you create a container on top of it. It should be like compatible. But otherwise, the two file system will have a hard time connecting with
Yeah,
each
are
other.
you saying that initially they created something where the base OS should be compatible with the
Mhm.
underlying OS? Then to deal with the problem that they should be compatible, they created this runtime engines that can now uh, deal with the compatibility issues, so that now you can run a different container image on a different OS.
Mhm.
Yeah, but like, still that solution exists. So it's not like they did it earlier. What Docker and other companies did when they were building container solution is they used this approach, like how the host OS can connect with the base image OS. So that's that runtime engine. It defines like how these two can talk to each other, like how Windows will talk to Linux system, or how Linux system can talk to Mac OS, something like that.
But yeah, I think this is good to know like how it got started and still it is exist.
Yeah, it still
I
exists.
always because I didn't know that, so this is good find for me.
But I think it's not as prevalent as we think, right? In terms of virtual machine, where you can just install any OS, like you can install a Windows OS on a Linux or Ubuntu, and that's going to be okay.
Mhm.
With Docker, you are limited to what she was saying in terms of what really will work. So I don't think you can have a Windows Docker container on a Linux.
No,
Or
that is possible. I don't need a wing. I, okay, let me put in this. I just need an image which I can load in a container and which would be running on Docker. Then doesn't matter where it is running. It is on Windows or Linux or Mac OS.
yeah, that's what I'm trying to say. Maybe there isn't enough compatibility available to, or there isn't a Windows image that you can run on a Linux machine, or at least that wasn't the case earlier on.
Mhm.
right?
So
So
there
you,
is
yeah,
something called as Fuse to answer your question. So what Fuse helps Linux is to connect with any type of file system. That's not a X system type of file system like NTFS or ZFS or something like that. Fuse helps to talk to Linux file system. So like a Docker container, like running a Windows Docker container on a Linux, I think should be a possible scenario.
yeah,
And I
yeah.
think today's your presentation is not on Docker. It is, if I remember correctly,
Yeah, it's not on Docker. Yeah, but
it's
it's just that
it's mostly like container on Linux.
Linux.
Can you remind me the entire thing? I'm
Yeah.
just trying to tell the audience that Shreya is not focusing on Docker today. Her more focus is on this one.
Basic containers and like how containers happen, so that we don't have to worry about like what kind of container like engine is running, like Docker or Linux or Core OS.
Mhm.
Just basically about containers. So because like there is this open container initiative where like whatever container solution you use, everything will be same, so that it is easy to implement one solution and switch to another.
Mhm.
So if you understand like just containers, that should be enough, and you will be good to go for all the whatever system you're using, solution you're using.
Yeah, I think that will be helpful.
Uh, okay, so this is what the container would look like. So as I said that there will be some base image, and then there will be some layer on top of it. So how it builds up. So let's see. Let me draw a diagram over here. So how layering would be done, right? Let me create a hierarchical diagram here.
What is layering and why do we need layering?
Okay, so layering, because like can I draw the diagram? I mean, I can then explain better, I think. So for example, this is something, this is layer one, and this is my base OS. Then I have layer two, and that's Ruby. And then I have some other layer, which is, and then here I was running Golang, for example. So basically, if you see, uh, so if we consider this first line as layer one, okay, then this is base OS, and on top of this base OS, I have this Ruby, okay, and Golang. And then inside that, I have this layer 3, which has Rails, some version 4.2 and some version 4.3. Okay, so the advantage of this is now since I have this base image, right, I can run something on Ruby here. Sorry, not Ruby here. Something on Rails here, something on Golang over here. So now what I'm doing is basically I'm reusing Ruby and base OS over here. So that is the advantage of layering. You do not duplicate. Like I'm not making something like, okay, I have a base OS and on that I'm making Golang, and I don't have a base OS and then on top of it which I have Ruby, and then on top of it there is Rails. So the idea over here is like you make things which are common as one image. So that if any time if you want to reuse something, you can reuse it. So like if I have, so you might have heard about these container registries. So they'll contain some base OSs, right? So they'll have this image. You can just directly go and use that image. Then they have some other image which will have like some web server running on it with the base OS. So you can just go and use that image. So the idea is reusability over here. So that, and also it dedupes like your files whenever you want to use it. Uh, so does that make sense? Or does it?
When you say base voice, right, I think I just want to clarify here a couple of things. So basically, right, in this containers, you have three components, right? One is the actual Linux kernel, which is the actually shared by all the containers, right? So one Linux kernel.
Yes.
Then you have the concept of containers, which is basically an isolation environment provided by the OS kernel, correct? So that each of the container, when they're running, they're isolated. And what container itself means, like it's kind of a root file system, right? In normal Linux, you have one root file system where every package installed, right? All the software components, everything.
Yeah.
But in container, when you say this base OS or images, you're basically talking about the actual container. I mean, like the isolated environment for each of these container is basically you're referring to here as a base OS means, right? So it means like you can have one base OS which has a one root file system with a very basic components, and then for each container you could have additional packages which are available only within that container environment for use by that specific container.
Yes.
Okay.
Yeah, you have got it all right. Yeah.
Okay. Okay. Thanks.
So this is the advantages of making a layer. So now how we will achieve this is through something called as namespace and control groups. So let's get into that, like what exactly these are. So yeah, some of the advantages of container, let's quickly go through that. Already we have discussed is like scalability is one, they're lightweight. And one of the advantages is that if, for example, you have some development environment, right? And you have some local dependencies when you created a project. So now you could have like different dependencies. The system is running in production that can have some dependent, like that is created with different environment, and then that other developers that are running the software in much like developing the software can have like different dependencies. So to like not have that dependency effect, and whenever you deploy and not have get into unnecessary errors where you didn't know, because like this environment was not created the way you created your software. All these things can be like avoided if you develop your system and then you test by deploying it into a container. Then you can just have that same configuration container over there, and basically you can ship it as is. And good, like once you have created a container, then you can just copy the same container again and again. You can just use it, so it will not, it's since it's lightweight, scaling the containers is super simple. You can scale it on the same host, you can scale it on different host, you can have a cluster. So that all is like really simple with containers. Then code your configuration is something which is basically not an advantage of container, but like because you have configuration of containers, you can basically, every time you make a change in your application, you can make it in such a way that your uh, runtime configuration also is the part of your code. So that for example, if you have a monitoring service and it sends you an alert whenever like there is for example, there whenever the response time is more than 1 second, then your service creates an alert. So whenever that happens like consecutively 5 times, then that is when you get alert, right? If you make some changes and this 1 second changes to 2 seconds, because now your expected response time is 2 seconds. So all these configuration changes, like this could be, instead of going and changing on on a certain different UI or some different place, you can just code it in your configuration. So this all becomes automated. Next is type of containers. So the system containers are, you can understand this as just virtual machine, and application containers are whatever we have talked about up till now, like the base image, and then and these are the container runtimes, Docker and LXC and CoreOS. And now like we'll come to the namespaces and control groups, which actually made Linux containers. So initially the concept was to have multiple user spaces in Linux. So by user space, it means like there are two kinds of spaces in Linux. One is user space, and the other one is and another one is called system space. So what happens here is, for example, this is some X system, and this is the kernel, and this is like system space, and this is user space. By user space, it means like whatever functionality will be doing over here, that will come here as a system call. And what uh, started with is like having these multiple user spaces, so for multiple users. So the container started growing up from there. So they knew like now you have to have these multiple system calls to the kernel for each user. And then they wanted to have like, because multiple users are using it now, they need to have namespace isolation. uh, Namespace isolation is basically like isolating the file system. It is like on multiple levels. You can isolate files, you can isolate network resources, you can isolate the user time sharing, the inter-process communication. So there are multiple
Just,
isolations that's possible.
1 second, just let's take a pause. Okay, so just let me give a summary. So what I think, so what we're talking about here is that VMs, the big advantage of VM was that you could get the isolation because each one of them was running in their own operating system. So so everything is isolated. Each one of them has their own operating system, so their own file system, right? And then we could also do the limiting. The other problem we were talking about is that each process should not be utilizing the resources more than how much we have assigned it to. So with the VM, if a VM has 4 GB of how much RAM it can use, then your process will not use. Right? Now we said we are not using a VM. We are using a container, which is not actually a OS image, but we still want the functionality of isolation, want the functionality of open source limiting. So how the functionality of isolation, that file system of one process is separate from another, that problem, and how you can achieve resource limiting, that one process will not take up the resources of how much it has been assigned, how it can be achieved through containers without actually creating OS image. That is what Shrey is explaining, right? So C group is what helps you do the limiting resources limiting, and namespaces is what that provides you isolation, right?
Yeah. So we can go for like, I can show you like how the mount namespace isolation can be done. So like you will be able to see that I'll mount a file system on a particular directory, and then only one of the process will be able to see it, and other processes will not be able to see it. So for example, if I have these two terminals, so I have these two terminals, and let me make a directory here. So I've created this directory, and now there is a system called unshare. I am using this to like unshare it with this bash. So now I have separated this namespace. So the bash process is now in separate namespace. So we can now let me mount that particular directory that I created above, temp mount new system one. Now I'll mount it with some temporary file system. So -t is for file system. Okay, so so this is the temporary mount point that I created. Now we'll see that if I can see this mount point from this uh, particular this isolated namespace basically. So I can see it from here, but how about from here? Because this is a different bash terminal. So I should not be able to see it from here. So yeah, I'm not able to see it from here. To make it more clear. Yeah. Different. Yeah, so there is nothing like that. So we got no such file or directory. But we were able to see it from this particular terminal because I isolated these two bash, because when I did unshare of this particular bash. So now whatever I'll do over here in this bash, it won't be shared with other bash terminals. Right? So this was like an example of mount namespace isolation, like how you can isolate the any directory with any process. In similar way, you can do like isolation on most of the things like Unix time sharing, inter-process communication, on processes, on user namespaces, and the network. So
This functionality which Linux has provided.
Yeah, this is the mount functionality which Linux provides.
And Docker is using this behind the scenes to actually provide the file system isolation.
Yeah, this is actually, so there are these system calls. There are, I think, 3 of them, which helps you do the isolation. So the most important one is unshare. So unshare just basically lets you know that I'm not going to share anything from now.
Okay. And so to achieve this file system isolation, the problem that we were talking about, so Docker is using this mount and unshare functionality of Linux to achieve that, right?
So mount is one of the type of namespace isolation. Unshare is the system call that uh, doc. Okay, you're saying that okay, Docker is using both mount and yeah, Docker behind the scenes would be using mount and unshare.
When they when they isolate it like that, would they have different clock, or they share the same clock as the host OS clock?
The clock will be same. It will be like host OS clock.
Yeah, generally you don't need, like, why would you need isolation for clock? Time will be fine to be same between the processes.
It depends on the application, right? But yeah, that's the case.
Time, first of all, is not that reliable. Like, but if you really need time, I think it's always the host OS time.
Okay.
Mm-hmm.
So before you do the sudo, that was like act as the root, right? So even as a root, they cannot see the namespace of the other user.
Yeah, it can't, I guess. Root should be, yeah, it won't, yeah. So like that's no matter, even if you're root, if you are like a part of one container, the other container shouldn't see anything until unless it's like you are exposing something. So chroot is another functionality. What chroot does is also helps in namespace isolation. I've not seen like I haven't seen the practical implementation of like wherever. I just saw the system calls, but like chroot is a Linux command line utility which helps you like change the root. So whatever processes that you're running, for example, there is this group of processes that you want to isolate. What you can do is just use the change root command, and you can tell those processes now your home directory is something else. So for them, what the view would look like is that now, where's the stylus? Yeah. So for example, there was these process from there were these processes from 1 to 10, and they were some group of processes, and what I wanted was these 10 should be isolated from this 11 to 20, and they both were running on this slash root. This was also running on slash root, and this was also running on slash root. With chroot, I can run the function command line this utility, and I can map, okay, 1 to 10 will be part of slash user 1 slash. So now 1 to 10 will think or feel like that it's running on the root, but actually this root will be mapped to this user 1. It will actually be running inside that user 1. So this is another way of getting the isolation on anything. Change root it is applicable on everything. So this is change root. And then there is control group. So control group is another feature that limits the resources and usage for the process. So I can show you an example or a small demo over here. So for example, so these are some containers, right? And I have there is a place, so quick some concepts. So lxe is Linux container, which we were talking about over here. What made lxe? So like this was the first. So Linux already had these concept of containers going on, and then this Docker and CoreOS, they started picking up from there, right? And what happens here is this lxe is nothing but a package, and it provides these command line functionalities where you can launch a container, you can start, stop, pause the container, you can take snapshots, you can restore. So I'll show you a little bit functionality over here on how they are doing it. And you can also limit your resources like memory and CPU cores if you want. So for example, if I want to launch a container, how will I be able to do it? So there are these registries. So like you have, most of the few are familiar with Docker. So like how Docker has these registries, right? Public and private, where you have your images. Uh, these are the repositories or registries of Linux containers, as you can see. So the command is lxe remote list, and these images, these are the places from where you can get multiple images, right? Maybe if I click, I should be able to show you. No, not working. Yeah, I don't know why it's not working, but like, yeah, if you'll go, there will be like bunch of images over there, uh, which will have like Ubuntu, CentOS, Alpine, and all the version of it. And there is something called as profile, which actually helps you limit the resources. So over here I have like, so by default you get one profile, that is default, but here I created this custom profile, and we can see like uh, what this profile has as the part of, yeah. So like these are the configuration. I have put this limit to CPU as 1, and memory is 512 MB. And for default it will always use like whatever you have in your whole system. Like if you have 4 CPUs, it will by default take all 4, because we haven't done any limiting over here if you compare the two files. So here, like after config you have this limits, but here after config you have nothing, it's like empty brackets, right? So this is the config. Now if I have to edit anything, so like if I want to, for example, edit the default one itself, so I can just go here and then add the limits. So if I have limits dot memory, for example, and it's a YAML format, so for example 512 MB. So now whenever I launch the image, by default it will consume only that much memory, right? I can show you this. Let me just revert this change so I can show you like both the examples. Okay, there is some error in the YAML. Okay, so this is fixed. So for example, if I have to go inside any container, okay, let me first show you how to launch a container. So the command is simple. It's lxc launch, and whatever the image that you want. So lxc launch, and uh, for example, I wanted to install Ubuntu 6.04. So now it's creating the instance over here. So now, since I didn't specify any name or any profile with which I'm creating, it will be created by default. And the name over here is arriving earwing. That's the default name that's been given. So the latest container is on the top. I can go inside this container and I can see what's going on in that container. Yeah, so now I'm inside this container. I check the host name, and then so now here the host name is this. Here the host name is different. Also, like the kernel version are different. No, kernel version is same because it's like the image. Yeah, the version of Ubuntu would be different. So this is Xenial, and this would be, let's see, this is Groovy. So they are like two different operating system running. So we are inside our container. There is nothing over here. There is like something in the file system. Uh, that's it. And we can see like the memory that is being used. So it's like 488 because in the default, we specified memory to be like how much it was, 512 MB. So now it will be using between that. So we limited memory here. Then there is nproc, which is basically telling you how many core is the CPU used. And here also, like if I see nproc, the number of CPU used is, sorry. So here I see the number of CPU is 4. Now I can limit the CPU by, specifying that, okay, I don't want you to use 4 CPU, I just want you to use 2 CPUs, for example. So I log out of this machine, and when I launched this Ubuntu, right, I could launch it with my profile that I created, the custom one, which allows the container to use 512 megabytes of memory, and only 2 CPU, I guess. Let's see. So this will create an image with whatever limiting of resources that I defined. So here, let's see. So yeah, the CPU limit is 1. So now whatever container will be created will have the limit of 1. Sorry, my command was wrong. My VM2 or my VM, and then I should specify profile custom. So it created a, so what happened there was it created a image with name custom rather than using the profile custom. Does anyone have any doubts or any questions up till now?
So one question here. So all the commands you ran so far is to show how Linux implements the containers by set of commands.
Mm-hmm. Yeah.
And Docker took those ones, and they created a very good. They had all the complexity so that these things are similar to whatever you runs inside Docker container as well.
Inside Docker containers,
The Docker engine basically.
yeah, I get that. Like, I really don't know whether they are using exactly LXC commands or they have their own other implementation. So I cannot answer that.
Okay, but they took the concept from here, right?
Concept was taken from here, yeah.
Okay, thank you.
So now my VM is created, and let's go inside this new VM that we created, and let's see if those resources were limited or not. So Alexi exec, and the name of my VM was my VM, and let's open with bash. So now if I'll see the number of CPU, it's 1. So, and the memory again, like, will be the same that we specified. Compared to our original machine, the CPUs are 4 and memory is like complete memory. So this is like how you can limit resources. I mean, I don't know, but like you might have got a good idea about how you can limit the resources using control groups. So like all these things are now abstracted through command line utilities, or in even Docker, there would be some commands to limit these resources and provide the isolations.
Could you explain a bit about the snapshot?
Yeah,
What's on the console?
okay, yeah, we can talk about snapshot. So let's say this was so right now in my directory there is nothing, and this is the VM, and I created some directory 1, 2, 3. So now I should have these 3 directories here. Oh, sorry, created like 1, 2, 3 exactly. So I created directory 1, then 2, and then some directory 3. So now I have these 3 directories, right? And now what I can do is I can take snapshot of this directory. So I log out. I take the snapshot of this container. LXC snapshot of my VM and my VM snapshot. So the snapshot is taken and we can confirm it by LXC list, which lists all my containers here. So, so my VM now has a snapshot. So snapshot is 1. And now what if I lose something? For example, I go inside my VM and I had this directory, but I kind of by mistake deleted these, right? So now I'm left with no directory. So what I can do is I can restore using LXC, restore my VM from my VM snapshot. Fail to fetch snapshot my VM snapshot of instance. Though I think spelling is wrong. Yeah, so now let's go inside it and let's see if everything is restored. So 1, 2, 3 are restored now.
I see.
So this is a snapshot and yeah, and how to restore from snapshot. Yeah, that's it. And apart from that, I think it will be nice to give it a try on your own. I'm still, yeah, I also gave this a little try. I could understand like things. So here in this slide, I was just explaining like how Cgroups are limiting resources and on what basis. Like you can do 2 things: either you can do accounting or you can specify limits. Uh, because to specify limits you need accounting, right? Like how many processes will be using, and you can limit on not onto just the containers, but you can also limit to like in not to just memory, sorry, and but also to processes. So that's a valid case, like if you want to limit the processes and not just memory. uh, yeah, that's it. And that was the demo. Apart from that, it has just like things like stop and delete. Like if you have LXC list and if you want to delete a container. Oh yeah, I can talk also about like nested containers. So this is a container, right? Inside that I can actually have another container in it. So that layering concept we talked about, that could be implemented here. So let's see if we have LXC installed, because this is new VM. By default, LXC won't come. Apparently it has. And let's see LXD. You need LXD because like all these LXD runs on top of LXC, and all these command line utilities initially wasn't there. You were supposed to write your APIs and all, but now you can have this LXC utility and then run all the all these command line utilities to do listing and launching of containers and stuff. So right now I shouldn't have any containers. So this might take a little while because we are running containers first time on this. So yeah, there are no containers over here. So we can create or launch the containers in the same way we did in like the previous step using the same remote images. Um, and just on top of it, run anything that you want or any image that you want. That's yeah, that's that. And yeah, I was showing like LXC delete, I guess. So I can just delete my VM. Sorry, first I have to stop it and then delete it. So stop my VM and then I can just delete the VM. Uh, there is something I can also talk about because there is like half an hour with us. There is something, a concept called copy on write that we can talk about, and I kind of missed it somehow. Uh, so, copy on write is a way like how Linux manages its uh, files, like changes or updation on files. So that's also like the way how Docker or any of your containers will do it. So it's good to understand. So for example, you have some file and you have 2 3 and this 4. Now assume that you wanted to replace 3 with 5. So the ideal way, like generally people think is, okay, I will just override 3 with 5. But what if this is a multi-threaded system and somebody could was reading your this tree, and we might find this tree in a very inconsistent state, right? So there is a file system called btrfs, uh, and this provides the functionality of copy on write. What copy on write is here is to see the structure always consistent no matter what. So you have 1, you have 2, 3 and 4, and now you want to add something which is 5, right? So in order to add that, what you'll do is you'll add 1 pointing to 5, and then this one you will create basically copy of this root and add the new element over here, and then point it to the its left is going to point it to the same thing which was earlier. And later, once this whole mechanism is done, you, for example, this was your root, you will now change it to this, that this is your new root, so that the system is consistent always. So how this will look like in a container is basically, for example, you had some file sorry, you have some container C1, you have some container C2, right? And this C1 and C2 both wanted to look at a file under this in this host OS, which was not necessarily not thought of like so basically not a dependency, but some file which like is provided by host OS. So for this, for example, this was file.txt, right? And both C1 and C2 wanted to have this. So what will happen in copy and write is C1 will have uh, file .txt and C2 because now C1 has modified this file, assuming that C1 container 1 has modified this file, C2 will be able to see that file exactly because its root is the same root that was before. But C1 won't be seeing the file. So basically, if C2 was the one who updated our C1 is the one which updated our dash, then C1 will be able to see our dash, whereas C2 will see only R. So the root here are different. So both are like seeing the same file, but in like different contents.
That's how they separate the space, but still sharing the under file system.
Yeah, that's how it will look like. Yeah. Yeah, I had only this much to share about. If you want, we can discuss more related to it. That's something to add. Sorry.
It seems like every time you create the container, it automatically create an IP address for that container, right? Can you go back to the console?
You mean the IP address as an address?
Yeah, if we go back to the console, I see that the. Can you scroll up a little bit?
Mm-hmm.
Yeah, right there, right? So every container have its own IP address.
Yeah. Yeah, so when you will do something called as LXD in it, it asks you like you want a bridge, you want to create a container, like what kind of network functionality do you want to provide? Because since I already ran container over here, it's already was configured. But yeah, then it's like dynamic allocation of IP address. You can also specify the range here. Let's see if I can run it somewhere. Let's see if I can run in. This is a messed up container, but let's see if I can just run LXD in it if allows. So yeah, so you can see, right? It wants to configure a new storage pool. If you want, you can say yes, if and it will create for you. And the name of the directory, whatever you want, I generally go with directory. And then here, you were asking about would you like LXD to be available over the network? And then if you do yes, and then address to bind the LXD to. So whatever address you would want to bind it to, right? And then port to bind to, and then trust password for new clients. Yeah, now this is the bridge. So this is the bridge where you will have these configuration. Yeah, I was talking about the network configurations. So by default, like I selected no for everything, and even for the IP address ranges, it will give option for ranges also. So like I think there is some problem, but like you in general, like when I initialized it in my host OS, it gave me the option of providing selecting the range also. So you have this option, yeah.
So I believe this is also a functionality of Linux namespaces.
Yeah.
Like you can get isolation of domain names that each container image could have a different domain name. So as per Wikipedia, like UTC is that namespace. So UTC Unix time sharing namespace allows a single system to appear to have different host and domain names to different processes.
Yeah, Unix time sharing do provide that, yeah. So whatever that those 6 things are, right? Whatever functionalities they provide, like inter-process communication or Unix time sharing or mount or process IDs, they all can be like isolated with.
is there a share space or share file so that our container can see the same space?
There are for example, there is some thing called as notepad, for example, that we know can be used by everyone, right? I'm just giving a really simple example just to imagine. So then by default, right, we will give the notepad as a functionality of host OS, because we know that everyone is going to use it, and there is there will be no modification that will happen on notepad software. So something like that. Then it will be on host OS, and then everybody will be able to use Notepad.
Okay. What would be the preferred way for one container to talk to another container, or to send message or data to another container?
Okay, since containers are running, I think we should be able to just ping them. Let's see. So I have some other containers. Let me do Lexi list here so I know the name. So arrive custom is easy name. So let me just ping custom. So yeah, I'm able to ping custom, and I think if I know the IP address, I think we should be able to do some sharing and all through, if I can get SSH access to that container, that is one way. If I can use some FTP server, if I can run between both the machines and then they can share files. I think all these things are generally done by Kubernetes, right? This is the that's the orchestration that will help, how containers are going to talk to each other, connect with each other, and how they're going to scale in the network. But yeah, if I have to talk to another container, what I need is I can run, for example, if I need file sharing, I can run FTP on VM, this my VM2, and then I can run FTP on custom. And I think with IP address and the URL, I should be able to see the directories that files are exposed, and I should be able to download or upload.
Cool. Yeah.
Has anyone worked on something like that? I've never worked on any deployment solution.
You mean like deploy an update to all the container?
Yeah, actually deploying your application on, Docker containers or something like that, or any other container solution. Oh, okay, Asim, I'm done actually. So if you want to go ahead and wrap it up, I'm fine.
Okay. Thank you, Shreya. Thank you so much for running this session. Let me first stop the recording.